Okay, so let's take a look at some slant asymptotes. So let's take the function y equals x squared over x plus 1. So we're going to graph that thing. So I'm going to set up my graph. And I want to start off with my vertical asymptote. So vertical asymptote, we know the denominator, x plus 1, equals 0. If I subtract 1 from both sides, I get x equals -1 for my vertical asymptote, and I can put that in the graph right away. X. Perfect. So now we want to look at the horizontal asymptotes. And we learned that in 9.1, if we have case 1, where the exponent of x is higher on the top than on the bottom, we have a potential slant. So the exponent of x on the top is 2, and that's greater than the exponent of x on the bottom. Therefore, horizontal asymptote is none. But we might have a slant asymptote. And we need to find that slant asymptote by doing long division. So bottom goes into top. So x times what is x squared? Well, that's x. Now we'll take this x and multiply it by both of these things. So x times x is x squared, and x times 1 is +1. I'm going to put a 0 up here. So then I minus. Excuse me. X times 1 is x. Now I'm going to do subtraction. So x squared minus x squared is 0. That's gone. 0 minus x is -x. So now I can continue. So x times what is -x? Well, that's -1. And then I can multiply this -1 by both of these things. So -1 times x is -x, and -1 times +1 is -1. If I do a subtraction, -x minus -x is 0. And I'm going to put a 0 here. 0 minus -1 is +1. So then I can write it in the other form. So I know the top divided by the bottom is equal to the answer, x minus 1. Now remember, this is the remainder, and we say plus or minus the remainder over the original divisor. So if we do long division and change it to the other form, the answer, the top, y equals x minus 1, is our slant. So that's in y equals mx plus b form. So we have a y-intercept of -1 and a slope of 1. So I'm going to put in the y-intercept of -1 and a slope of 1. Angled slant asymptote. Much better seen in the graph. Now outside of that, we'll just want our table of values points, but I'm going to let you do that on your own, and I'm just going to draw in the points that we've gotten. So, as seen in the notes, close to the vertical asymptote through the point, close to the slant. And then, as you can see in the notes, it kind of goes, I'm just going to extend this axis down a little bit. So again, it just goes close to the asymptote, through the point, close to the asymptote. So just a summary of what that graph looks like without the asymptotes. Just a funny looking graph where we can't cross the vertical asymptote and we can't cross the slant asymptote. So now we've seen vertical asymptotes, horizontal asymptotes, and slant asymptotes.